All right, MSM2, today we are talking about surface area of a cylinder. Students will be able to find the surface area of cylinders. There's a quote here, an army marches on its stomach. In this unit, we are going to talk about tin cans, or if you think about like a Campbell's soup can or a can of vegetables, that's sort of the reference that we're thinking of. What two-dimensional shapes can you cut from a piece of tin plate to make a cylinder? Well, if you look down the page, you can see that we would cut out two circles and a rectangle. The two circles being the top and the bottom. If you've ever opened a can, typically you use a can opener, cut off one of the circles. There'd be a circle on the bottom that would be matching. And then the lateral area is the rectangle that wraps around. It says a tin can is made, what factors might a manufacturer considering before designing a can? One thing might be portion size, another might be the shape of the contents. That's a big one. If you think of trying to put asparagus in a can versus trying to put green beans in a can versus putting, say, sliced olives in a can. The shape of the can would need to be very different for the asparagus and the green beans that it would need to be for the olives. So one is the shape of the contents and another might be portion size. If you've ever bought anything at like a Costco, they tend to have much larger portion sizes. A tin can is made by cutting two circles and a rectangle from a sheet of tin plate. The rectangle, or lateral area, is rolled into a tube. The circles are added to the ends of the tube to form a cylinder. The entire amount of tin used to make a can, the sum of the areas of the circles and rectangle, is the total surface area. In general, surface area of a space figure is the combined area of all the figure's outer surfaces. So how is the area of a circle found? We just did area of a circle. Area is pi times the radius squared. How would you find the area of two circles? Well, that's easy. It would just be 2 pi r squared. That would be for these two circles over here. How is the length of the rectangle related to the circles? So the length of the rectangle, how long the rectangle needs to be, if you think about rolling it up into a tube, it would need to match the circumference of the circle. So the circumference would be pi times diameter. Well, another way to write that, since area is written in radius form, another way to write that would be 2 pi r. Pi stays the same. The diameter is worth 2 radii. So how is the length of the circle related? How is the length of the rectangle related to the circles? It is equal to the circumference. What formula is used to find the circumference in terms of the radius? So typically, we would say that circumference is pi times diameter, but in place of that, so that we keep the radius as our one and only variable, we use 2 pi r. The lateral area is the area of just the rectangular part. What formula would be used to find the lateral area? Well, typically we would say that the area of a rectangle would be length times width. Well, on a cylinder, we would have the height of the cylinder. Well, that used to be our width. So let's go with area equals, instead of width, we're going to use height. And then the length is now 2 pi r. So we're going to write 2 pi r times the height. So what formula can we use for lateral area? Length times width is going to be 2 pi r h. So if we want to find the total surface area, we've got to do the two circles and the lateral area added together. That means it's going to be 2 pi r squared, that's for the two circles, plus 2 pi r h, that's for the lateral area, or the rectangle. If you've ever bought Campbell's soup, the Campbell's soup label wraps around. I don't advise doing this to your parents just to drive them nuts, but if you were to slice off the label on a Campbell's soup can and unroll it, you would find that it is a rectangle.